This video is a video about how to install the 360 MXDBC Eaglevision system. Here you can see a picture. When the cover is removed, you can see it has some stands, left and right, 4 stands. Normally you place this machine over the track. We'll see that in a minute. You see that there is a control box here. Sometimes when you place it over this track, the control box, you wanted to have it here, or maybe you want to have it on the other side. Okay, so this is the camera houses. This is the camera plate. So the camera houses are inside the camera plate. Okay, here you can see that there is a plate fixture where you can put in a calibration can. This fixture comes with the machine. You must make sure that the height of the track is exactly the height where this fixture reaches. We're going to see, so this is a camera house. Inside the camera house you can see a camera. So this is the camera, and now we're going to look at it from another point of view. This is a 3D point of view. You see the same camera houses sitting in the camera plate, and inside the houses are the cameras, and the cameras look down. They look down and they find a mirror here. Let me see the mirror. Yes. So if I remove the plate as well, you can see that the cameras look down on the mirror, and then it is reflected, and everything that is standing here can be seen in the camera. You can look at it from top and then turn on some rendering. So now it's rendering, and you can see that if I look a little bit closer, you can see that the mirrors actually see the can standing here. So from this camera point of view, you see if I can see that. Yeah, it's a little bit difficult, but you can see here that you'll see exactly the picture here on the left. So here on the left, you see what the camera would see from its point of view through the mirrors. Okay, so take off the rendering because it's very slow. So the can moves from left to right. Right? So if you look here and you see the housings and the plate, you can see that the can moves through the cameras, just like this. So you will have to put the track through the system in this direction, and then at one point in time you see it appear here on the left, you see it appear here in the camera view, and suddenly when it is in the center, it will take a picture. And when it takes the picture, it will take the picture with all 6 cameras simultaneously. So you got 6 of these pictures, and then the pictures will be processed. Okay, so the can continues, and then it needs to be processed, the pictures, and when it's being processed, it knows when the can is a good can or a bad can. So it reaches the rejector, and then if it's a bad can, it will be rejected, just like this. So it comes here, it will be rejected, or it will pass if it's a good can. Okay. As you can see, the can comes from the left, and it reaches the laser sensor here, So it comes here, it reaches the sensor, it covers the sensor, and there is a encoder inside the motor of the track, and it starts counting the moment that that the sensor is uncovered. So what happens here is, so now it starts counting 1, 2, 3, 4, 5, 6, 7 millimeters, and when it's in the center, so it knows this distance in millimeters, it will take the picture in the right moment. In the end, we will have to adjust that distance so to make sure that it will take the picture at the right moment. The can must pass perfectly through the center of the system. So it can be left or right. So it can be here or it can be there. It must be perfectly passed through the center of the system, and that is also the center of the track. So you must make sure that if you position the system, it is positioned in such a way that it is perfectly centered. Okay? What are the things that we have to take into account when we place the system over the track? Well, one of the things that we need to be sure about is that a second here. One of the things we must be sure about is that the track is leveled. Okay, because if the track is not leveled, you see here. So if this one would rotate, you can see in the camera view that the can is not standing straight in the camera view. So what happens then is that it would not be able to process the picture correctly. So you will run into trouble. So the track must be leveled perfectly in let's say in X, and in lateral also. So if you do this, it also doesn't work. See? It will also get problems. So the track must be perfectly leveled. And then, when the track is leveled, and the can is standing in the center of this camera field, then it's also not possible to rotate this machine. So this machine must also be leveled to the track. So if you level this track to the ground with a level, you can also level this machine like this and make sure that it is perfectly leveled in this direction, and of course also in this direction. And also you must be sure that it is in the center. So if the can is in the center of the track, and I move this let's say in the X direction, you see you got trouble. If I move it in the Y direction, of course you also get trouble, because the can is not going to be in the center. It's going to be bigger. It needs to be perfectly centered, and it needs to be leveled. All the adjustments of the cameras that are done in the factory, so if it's okay, then in the end when you put on the machine, there must be a way to place it in such a way that the can is in all 6 cameras looking the same. So just like this, and that it is in the center of the camera, and it also is exactly the same height in every camera view. So if we would take another camera, where is that? Second. So I take, for example, camera 4. Then I need to turn on this one. going to be very difficult to actually see that. So we cannot do that easily. Okay, good. So what's important is that this is leveled, that the can appears in the center of all images, and that that is leveled. That's important. So now when the can comes in, the machine needs a way to process. There needs a time to process the images of the can. So it processes the images, and now it needs to know. Here it needs to know if the can is good or bad. So the distance between the center of the camera where the picture is taken and the rejector is important. If it's too short, the system is not able to know at this point where if the can is a good can or a bad can. So it needs to know that. So that means that if you think that now, for example, if the can moves at 1 meter per second, maybe no problem. But if the can moves at 2 meters per second, that's quicker. Then maybe the machine is not able to know if the can is good. So if the machine doesn't know if the can is good at that point, it will always reject it like this. So in that case, you will need to put the rejector further away. Well, if the can goes 1 meter, 1 meter 20 per second, the manual says that you can put the rejector at 60 centimeters away, 600 millimeters. That's a standard number. But if the track, some can manufacturers, they produce very quickly. So they need to have the cans move, let's say, at 2 meters per second. And if they move at 2 meters per second, definitely, then you need to have the rejector further away, say 2 meters or so. No, 1 meter or 1 meter 50, or even 2 meters. We have systems that have it at 5 meters. It works, but of course that's not necessary. But the minimum distance at fast-moving speeds would be 1 meter, 1.5 meter. And if it's going slow, most customers that have the system with filled cans don't go so quick. So they can have it at 60 centimeters, no problem. Very good. Then let me see, what more can we say here? Leveling cameras. This is about it. So the positioning is important. So the machine must be positioned. The height, so the positioning height. So if you look, the system comes with 2 fixtures. I'll show you the fixtures here. We have that in the system. So if I start this here, one of the fixtures I put in the system right now. This is a fixture. So if you go back to the drawing, you see that the system is now like this, and there is a fixture here where this calibration can fits in. So if I would add that calibration plate, this is the calibration can, I can add the calibration plate. You put the size a little bit bigger, like 30 by 1, or it's too much. 100, of course. Oh, wait a second. 100. So you got this calibration, it's like 3 millimeters, 0.4 millimeters thick. So this is the calibration plate, and it fits in fixtures here on the left, on the right, and the calibration can fits in that calibration plate. Just like this, and if it's there, so if you put in the calibration plate and you put in the calibration can, so if you would move this, it would move the can with it. But this is fixed distance compared to the machine, because this calibration plate is placed into fixtures that are connected to the machine. So in this case, if you look, and if it's sitting inside the calibration plate, which has a hole in the center, you can see here. So we see this. If you remove it, you see that there is actually a hole in the center of the calibration plate. Then it must also be perfectly in the center of the track, and also the track height, as you can see. So if the machine is correctly positioned, the height is also perfect. You see here the height. So the calibration plate perfectly aligns with the top side of the track. So if that's all fit, so if the machine is perfectly aligned with if the calibration plate is perfectly aligned with the top side of the track, if the calibration can inside the plate is then in the center of the track, and if in the camera view the can is always in the center in all 6 cameras, then the machine is in the right position. Good. So that is the height, and it's about the height. So the height of the tool, the tool can be heightened and lowered with the special standards that are adjustable, but that's in the manual. You will find that in the manual how you can higher and lower those standards. Okay. That's it for this course.